Manufacturing Solutions. But before we begin, let's review a few housekeeping items. First, participants will be on mute, but we do look forward to your questions and your comments. Please use the questions chat box on the right-hand panel to pose your questions, and we'll have Charlie speak to them during the Q&A session. We will be posting a recording of the session, and we'll email you the link so that you can use it and share it with your colleagues. Finally, in April, we plan to have a discussion of metrics with John Jackie of Altavia Consulting. We'll be sending out the announcement when the details are finalized. We are most fortunate today to have Charlie join us and discuss the latest efforts and works of the ISA 95 Best Practices Working Group. Charlie is the president of the 21st Century Manufacturing Solutions and consults on manufacturing and supply chain systems. Prior to founding 21st Century, he has worked with automation vendors, including GE and ASECO. He has been a manufacturing management thought leader and active with MESA and ISA, and also has contributed to a range of standards for ISA, SCORE, OMAC, and the like. And today, we mark the publication of the latest book from the Best Practices Working Group, the MOM Chronicles. Welcome, Charlie. Look forward to your conversation.
All right. Thank you very much, Jeff, and I want to thank everyone for attending our little launch session here today. And so our latest piece of work from the ISA 95 Best Practices Working Group is Book 3.0, and it's entitled the MOM Chronicles. And so let me, before I get into discussing the book, let me give you, for those who are not familiar with the ISA 95 Best Practices Working Group, who we are and what we've been up to for a while now. So we are a chartered ISA standards working group, and our charter is to basically write down best practices for ISA that apply ISA 95 in some sort of system implementation or actual technical application itself. So being able to take the various parts of the standards and do as-is manufacturing operations and define them as a reference model for the requirements for the manufacturing operation management systems. We write papers on how to establish, go from your as-is world to that common terminology and data models. How do you get there? We write papers on how to characterize and define the to-be and build the migration roadmap to get there. The group was founded in 2004. I was the founder, but I had a lot of people helping me at the time. We sat down with the primary goal of writing methodology white papers, so that people would basically understand how to apply the standard in various ways. Well, to date, since 2004, across now 3 collections of white papers in our 3 books, we've produced 24 white papers through a true peer review process. And what I've done is, over the years, I go out and I seek specific authors to write on specific topics, and then I get contemporaries, literally from around the world, and I typically get anywhere from 5 to 10 reviewers for every paper, and that's why every paper takes anywhere from a year on the low side to typically a year and a half to 2 years to complete, because by the time it goes through the review process and the editorial process. It's been literally a global effort. We've had authors and reviewers from 18 countries in producing the works that we've done. We put them into basically 3 books. Book 1.0 was Hitchhiker's Guide to Manufacturing Operations Management. Book 2.0 was When Worlds Collide, Um, and that book in particular was given the ISA's Best Standards Book of the Year in 2011. And then our new book is the MOM Chronicles, Book 3.0, and so that's the overview we have of our group.
Your sci-fi titles and images are not the least bit subtle, but your work in the books really contains some well-grounded real-world content. Just for curiosity, why did you and your group develop the science fiction-themed titles?
Well, we did so because many people in our technology space, are futurist, and we are constantly on the bleeding or the cutting edge, and so we look at, if you read sci-fi, it is actually sometimes a predictor of what is to come. And many things that the papers address are how to move from the current paper-based manufacturing world we live in, with some disparate IT systems, into this integrated, intelligent manufacturing world. And that is a bit of a futurist view. And so, in that same regard, we've taken this book and dedicated it to Ray Bradbury, who is the author of the Martian Chronicles, who we basically, spun the MOM Chronicles name off of. And I want to just have a brief explanation of Ray Bradbury, since we did dedicate the book to him. Ray Bradbury, produced futuristic works in the 20th century that influenced many of my contemporaries and myself as technologists and scientists, basically to try to influence the world in a positive way to make it a better place. Ray Bradbury passed away last June, and he was an author of many books, but of celebrated literary works were his Fahrenheit 451, the Martian Chronicles, the Illustrated Man, Dandelion Wine, and Something Wicked This Way Comes. He received many awards, including the Pulitzer Prize special citation in 2007. But the MOM Chronicles is an extremely interesting book because it's a collection of short stories like our books as in the working group are a collection of white papers. And the MOM Chronicles was written in 1940, but it was written in today's time. So where humans colonized Mars in 1999 in the Martian Chronicles, and then basically in them trying to colonize Mars, basically they found themselves conquered by that planet. And there's a parallel here, and the parallel is in that the way that humans in the Martian Chronicles attempted to colonize Mars as they would Earth. They found that to survive and exist and thrive on Mars, they basically had to harmonize with the planet. And this is what we've seen really in manufacturing operations, in that you've seen a top-down effort to attempt to apply ERP or types of methodologies to do real-time work process type applications, and there's been a pretty high failure rate. And basically, in order for to be successful in applying manufacturing operation management systems, you need to harmonize with the plant floor and conduct that harmonization effort such that you're able to understand real-time work processes and design systems that support them and allow them to change. And that's so there's a parallel here between the Martian Chronicles and the book and the books and the works we do, because we try to explain that you need to address what we call the manufacturing operations paradox. where 80% of the solution is going to be cultural and 20% of it's going to be technical. And understanding that going in, that a manufacturing environment, even if you make the same thing in 2 different plants on 2 different continents, the culture of the people and the local labor laws and regulations, as well as how they go about decision making as a culture, will influence the form of your manufacturing operation solution. And Bill Gates alluded to this in one of his quotes that I like, where he said the first rule of any technology used in a business is that automation applied to an efficient operation will magnify the efficiency. The second rule is that automation applied to an inefficient operation will magnify the inefficiency. And this is really the lesson that we've learned in trying to apply manufacturing operations over the last 15 or 20 years.
Well, with that thought from Gates, have you identified any reason why manufacturers don't do the necessary process evaluation and re-engineering before they implement MOM systems? I mean, it's always seemed to me like they're missing a really rare opportunity to step back, analyze what they have, and get it right.
Well, the answer is that it's hard, for one, but manufacturing from the 20th century became very departmentalized, and the organizations still are. And so over the last 20 years, as manufacturers have been attempting or been applying some successful manufacturing IT type solutions, they did so at a departmental level, and they did so for good reasons, to reduce paper and to address the need for analysis within the department, be it scheduling or maintenance or warehouse or production or scheduling. But the overall operations work processes for a plant are typically not mapped or engineered as part of each department's system requirement. So they really don't have an engineered work process through the plant because of the constraints that the organizational structure has been put on it. So after 10 years or so, a plant ends up with typically 10 to 20 systems, departmental systems, that are using many different definitions within those systems to process a single production order. And this has led to poor data integrity as people try to do overall process analysis or optimization, and as well as to ultimately poor decision making.
Yeah, I know that we've seen that whole issue just with variable naming in trying to put together manufacturing intelligence type of applications. And you're right, given the different manufacturing databases from all the different departments that built up over time, different purposes, it's no wonder it's hard to get it going. But and the solutions that are out there, either do it right in the beginning and get the naming in order, or you have to create and maintain a cross-reference data dictionary to be able to do your analytics. What are you seeing as you work your practice as to how to move the manufacturer forward and get to the point where you can really take an enterprise view out of this stuff?
Well, there's been a couple of initiatives, but in general, companies get there the hard way as human beings, and basically we do point-to-point interfaces and then realize that every time we do a new product introduction, a continuous improvement process, or scale the plant, we end up having to address the remapping of data between these 15 or 20 systems, and that high cost after 3 to 5 years, and some of the more innovative manufacturers drives them to basically say, we need an information model at the integration and manufacturing intelligence level. And there's been some great work in the last 5 to 10 years done by the Operation and Maintenance Initiative, the Open O&M, around writing a standard called the Information Service Bus Model, which has this thing called a common interoperability registry to basically do that that mapping, and so it gives you a place to manage your meta and your master data within the plant across these 15 to 20 systems as you migrate them towards the common definition. You're not going to change those systems of record that have been there for 10 or more years. There's got to be a business case to do so. But as the business case is generated, and you can migrate those applications, but especially their mappings to the common interoperability registry or information model. And there are, what I call the innovators, the top 15% of manufacturers that have embraced this technology and learned the hard lessons are moving that way with their architectures. And so with that, let's talk about the book a little bit. So the book has 7 white papers, and there was a tremendous amount of work put in by the authors and the reviewers to get this work out. I worked with them for 2 years on this work, and there's some what I consider to be cutting-edge thought leadership in some of these papers. The first paper is around the applying of global MOM systems using what we call manufacturing 2.0. The second paper is around the role of semantic models in order to have smarter industrial processes. And this paper addresses how to go about applying some of the semantic modeling within cloud technologies as well as within SOA technologies. And they address the change management question in there. The third paper, applying manufacturing operations models to discrete hybrid manufacturing environments, shows how to use ISA 95 Part 3's activity models to do the as-is and the to-be requirements and build a roadmap. It shows the method for doing that. The fourth paper, which is a paper we've been waiting for a long time, is defining an operations system architecture and show you that there are many different parts that are part of building a cohesive and comprehensive operations system architecture. And it's a review of what standards are out there and what methods and what the parts are. The fifth paper, a workflow-driven approach to MOM, gets into explaining workflow-based manufacturing intelligence. Instead of just building a portal, you actually build a role-based portal, but that role-based portal is also locked into, it is driven by workflow, the workflows that are occurring at the floor, the SCADA level, the operation management level, and within the supply chain and ERP level, and coordinating those sets of information. The sixth paper is a actual real-world application of applying ISA 95 for scheduling in a steel plant. It gives you the context and the benefit of doing so. And the seventh paper is also a real-world interface application of using ISA 95 and takes you through some of the questions you have to ask. So the focus of the book, really we step out there and we literally say that the current manufacturing leaders, and this is me pulling from experts from literally around the world, we feel that the manufacturing leaders have a very limited vision of how their, and this is very general, of how their plants must competitively operate in global markets in 2025. They're just starting to ask that question: how does my plant need to function in 5 years and in 10 years? But today they have a very limited view. The manufacturers do not have a concept of what the engineering costs are required to transform from a paper-based departmental world with independent languages in each department to a real-time artificial intelligence for the work processes, and basically get that big gain of 20 or 30% more efficient than they are now. The proven reality of manufacturing operations, is that it is manufacturing innovation. It requires iterative, continuous improvement processes around the systems, dictating the requirements for the systems. If you do the systems without considering, are the processes engineered well, and where do we have to engineer them to, the systems become actually a barrier to improving the processes. So by 2025, those manufacturers without paperless work processes for intelligent operations, they simply will not be very competitive at all. And the book lays down some of the foundations to basically start this journey. The book also explains what MOM system engineering methods are and how they organize the complexities of this 21st century manufacturing plant, and how it has a role in a real-time interactive role in a global supply chain. The book stresses not to trivialize operations, as many ERP applications will do, as simply a problem of equipment operations, material quality, or material consumption. That it is a problem of optimizing work process for the current demand state of that plant. The book also explains the operation process definition, which as a MOM master user requirement specification. So you actually do the engineering, the as-is and the to-be engineering of the work processes across the plant, break down those departmental walls. And so that as-is to that to-be re-engineered efficient operations that's then supported by an operation system architecture. Now that the to-be operations process definition, that determines the operations dependencies within the plant and the plant within its global supply network that it has to be a role player in. One of the biggest concepts, and we actually introduced it in book 2.0, is manufacturing master data. Is that we need to understand that manufacturing master data is different than PLM or ERP master data, and we need to basically synchronize and manage that master data through semantic computing methods. So this is an example out of the operation systems architecture paper. Basically, in that paper, for example, it explains how the steps of how to go about aligning your architecture with the business and the business drivers, and takes you through that step-by-step process of reviewing the business roadmap, discovery, the discovery process, then the classification against the standards of best practices step, looking at the capability that the plant needs, ranking steps against business initiatives, and then refining and drilling down to the high-value areas that you're going to address in your roadmap and within your architecture. Another example is this out of the workflow paper, chapter 5, showing you that if you look at manufacturing intelligence, not just as dumb portals, but as interactive portals that actually are built to serve purposes within different operational levels, and that you've mapped the interaction and the dependency of workflows within the SCADA level 2, within operation management, within the supply chain, but also across areas and departments in the plant, understanding, when something happens, how does that particular state cascade across the plant, understanding that cause and effect. And it explains, how to go about building a manufacturing intelligence that based off of orchestrated workflows. It's a very interesting paper. The semantic computing paper, takes you through a bit of a journey itself, and looking at understanding that where we've come with the exchange of data from system to system, and how we really have come to a point where systems, instead of architecting systems departmentally, we're architecting systems to basically enable and support business and operations processes. And doing that within, where we're at now, which is the information-oriented architecture, building off of the service-oriented architectures of the early 90s, and now this emerging idea or concept of semantic computing, and how we're going to do that within distributed systems or cloud-based systems. The first paper or first chapter in the book addresses this concept of global implementations that basically all are built off of localized implementations, and understanding that master data management using semantic computing allows you to basically create a structure to where a local plant, in this example, sitting down here in Sao Paulo, South America, it has its products, its assets, its processes, its specifications, its regulations that it has to abide by, and that's its manufacturing master data. And then looking at that plant within the corporate plant base of how it feeds its information into the enterprise information of quality, genealogy, compliance, performance, and product design. So it's understanding that you have to have localized master data that maps to enterprise master data, and using semantic computing and master data management methods, you're able to do that effectively. So that's basically our short overview here. I keep it short so we can have some questions. I'm looking forward to some questions from the audience.
Okay, very good, Charlie. And as they come in, we'll certainly ask them. One of the things I noticed in one of your book focus slides, was your mention of the operational aspect coming in, that it had often been trivialized in the past, and that's certainly, when you look at the whole ERP and transaction-oriented management model, they really don't seem to have any way to be aware of process and time series and operations, and that's a real problem. How do you do a CP Snow two cultures thing here and make this stuff come together so you can get a really functional system for enterprise management?
Well, so optimizing work processes within the operation management layer is a real-time optimization, and you have to. That's where the engineering comes in. You have to understand, when I have a piece of equipment go down, what are my alternative routings, and I need to communicate that back to scheduling, because I have orders to fill and I have WIP in progress. What's the most profitable way to basically reroute the work in process to fulfill the orders that make me the most profit around that downed that down work cell. And the same logic applies if I have I make bad product, I have a yield event, and I have orders to fill, I have WIP in play in the plant, what's the best way to basically manage that WIP and make money. And these are real-time decisions that you have to think through and engineer and come up with rules for, and have problem escalation or event or alert escalation built into your systems to take care of. When you look at, so those are real-time decisions, but they do affect the business processes, and you have to understand when certain events occur, you need to let the people at the business process level know that I'm only going to fulfill 80% of my orders. I'm going to be late on order X, Y, or Z, and I need so that they can execute their business processes as basically do the damage control to make the most profit up at the enterprise level. Now, one tool that works very well for this, there's two tools actually, and within the supply chain operations reference model, they use Volman diagrams to map basically the level 2 and level 3 KPIs or metrics, into the supply chain business process metrics and planning metrics. And the method described within the SCORE model works very well for driving an alignment of or an understanding of dependencies between plant side and business side data and process. The other one is the resource consumption accounting model, the RCA model. It does a very good job of also mapping the cost of activity-based costing within the plant, mapping that to the, which is more at a point in time than across a period of time, where when you look at financial metrics that are in the ERP, typically they are across a period of time, but understanding what the activity-based costing points in a plant or resource pools within a plant, how they affect those periodic financial metrics. The RCA model does that and more for actually building metrics frameworks and aligning or driving some alignment between the business process data and the manufacturing data.
Well, even with that, I think there's something of a temptation to use the data you have, as it were. As you engineer these systems, do you get much of an opportunity, or I would think you should, of evaluating what it is you really need? What I'm using metric A, but boy, things would be a whole lot better with metric B, and with defining a new key performance indicator, KPI. What do you find in the negotiation there? Can you give any advice to folks out there as to, yeah, we can get by with good enough, but let's make it really work?
Well, it's a bit of a battle, because you're going to have, departmental metrics. You're going to have people trying to put a given set of metrics across all of their plants. And that's where the Volman diagrams, I think, work very well, is that then you can, as people try to say, give you, more broad brushstroke, high-level metrics, and then mapping, your metrics that you need to run a given process into them. The Volman diagrams work pretty well, but and White Paper 5 gets into some of that as well. The other side of this is that the statement I made about that these systems have to be based on continuous improvement methods. The requirements need to be derived through that. And so by doing value stream analysis within the plant and finding the waste streams within the plant and building system requirements to basically track, alarm, and optimize those waste streams, and then for quality purposes at material transformation points, applying Six Sigma methods and having, understanding the variances, the variance in the waste streams, that there's metrics that are going to fall out of a Six Sigma analysis for the various variance in process, and out of the value stream analysis for the waste streams, and those are going to give you the metrics that you're going to need to be able to track, alarm, and respond to in order to keep that process efficient. And so those continuous improvement requirements need to come from those types of analyses, and ultimately the systems be based on them. Because that's what you're controlling to optimize. You're trying to control the waste streams or eliminate the waste streams and control the variances at the material transformations. And that's manufacturing.
Mm-hmm. Well, that certainly makes sense. Minimizing waste is, Toyota special.
But that's been the problem with MES or MOM is that it's been very top down, where people just want to track the visibility of the order. I want visibility of my order. Okay, great, but that's not optimizing your process. I mean, and I want to track the material consumptions so I can have my inventory correct. Well, great, you can try to reduce inventory that way, but you're only going to reduce inventory by not having to have safety stocks or buffers, and because you're making bad stuff or you're running an inefficient process. And so that light bulb needs to come on to people that the operation management system is not about just tracking an order or reconciling inventory. It's about optimizing process and building metrics that optimize process and making decisions on those.
Right. The continuous improvement world is, needs attention.
Well, there's been a gap between the manufacturing systems, and still is a gap, and the continuous improvement people. And when you apply them together is when you succeed. And when you apply them apart, it's a crapshoot.
Yeah.
So.
Well, certainly since CI is a tool that's going to give you a chance to get better performance.
But you want to hold that performance, and that's what the system does.
Mm-hmm.
And if you try to apply CI, I mean, I've been in so many what they call slide back situations. I fix a problem, and 6 months to a year later it comes back because we really didn't institutionalize the fix within some sort of operation management application, and so as soon as we move on to solving the next problem, we slide back on the old problem. So.
Yeah, well, I mean, and that's the lifelong lesson from the, Deming-Durant school of things, that you have to really always be aware of the different processes and monitoring them, improving them. And, I am curious, about your manufacturing master data statement, where you're, basically it sounds like it's describing the milieu of any plant, the very localized ground rules that you must take. Are they applying, as it were, a weighting factor for, some parameters coming out so that you can realistically compare performance for a plant in San Paulo versus a plant in Santa Fe? How do you handle that and get useful information between, say, the various plants you have around the world?
Well, so I think we have to differentiate between master data and metrics there. All right, but master data is your SOPs, your work instructions, your PLC programs, your calibration. I mean, so manufacturing master data is not just the BOM or the process definition in ERP. It's actually getting down to the data that's necessary to make something and to execute the process. And so if you are looking at a particular process and you have optimized, you found a best practice for a given method of packaging, for instance, and if I have that master data in an ISA 88 form, for instance, I am able to then take that master data form and apply it at that plant in Sao Paulo or in Tijuana, Mexico. If that packaging line in those 3 different places are all their master data is all structured in very OEM form or in a very site-specific form, it makes it practically impossible to take the best practice that you developed on that packaging line in Sao Paulo and transfer it to the other plants without a lot of reverse engineering.
Yeah. And how do you solve the 80% culture problem that you alluded to in that graphic in the presentation?
Well, it's harmonization. So you have to get people involved in determining that the as is and the to be requirement, and I mean down to operators, supervisors, departmental level people. So because those are the people who actually know the inefficiencies and the pains of the plant. They have non-value added work time every day, and they actually know the solutions to fix a lot of the problems. But what they don't know is how to come together and orchestrate the roadmap and then derive the business case to get the funding for the project. And so that becomes your cultural issue. Is that so? I'm in the maintenance department. I need an EAM system, or I need downtime tracking for my assets, and the people over in quality, they need a system to help track their specs, and the person on the floor, that they need some SPC. So they all cost money. They all are going to address real problems, but they need to get together and identify what we're going to do in what order to and what they find when you actually create these working groups, and Deming calls them process action groups. Actually, PAT teams, process action teams. When you do go through that exercise to derive an as-is and a to-be user requirement, and ultimately a roadmap, you'll find that people won't want to work together and understand that my EAM will work better if I get the SPC in before I get the EAM in place. So that you have companies just don't have that departmental dialogue to prioritize manufacturing systems in their business cases. So, so that's just one part of the cultural problem. But is tearing down that wall and getting people to work together to put together an intelligent plant.
Mm-hmm. We have another question here. Do you have examples of small m cap MDM applied in a sustainable semantic model? And does the book cover any examples?
Do I personally have examples of that? I know people who do. I'm trying to think of where that I could get that. there are examples out there. Some of them are just, and that's the problem we always have here, is that companies that have gone about doing this, they don't publish what they've done, but I've worked with them, or other people I know have worked with them, so they know about them. But there's some good work, and there's a paper in book 2 by Dennis Brandl that explains some of that mapping. I believe that the manufacturing master data paper itself that's in book 2 also addresses that and has some examples in it, as well as the SOA for manufacturing paper that's the first chapter in book 2 also has an automotive example in it. So there's a few just off the top of my head, but so you really have to go back to some of the work in book 2 to abstract some of that out. The paper 5, the workflow, the manufacturing intelligence with orchestrated workflows, does address it as well. So.
Okay. Another question: what industries, and be it food, packaging, pharma, whatever, do you see really trying to do this and actually making inroads, especially as far as an industry trend? Do you see any differences across the industries?
Well, the packaging industry and CPG, especially with the work they've been doing for years around make to pack and soon to be part 5 of ISA 88. So they've made some great strides there. I think they still have a ways to go, but they speak to the method from the ground up, literally from the equipment state model, and the need to rationalize state models in order to have data integrity across packaging lines. That applies to pretty much any plant, though. But when you get to industries that have just really, if you would have told me that the food industry 15 years ago were going to be some of the leaders in applying operation management technologies, I would have told you were crazy. But the food industry's come a long way, especially the brewing industry. Some of the most intelligent plants in the world are actually and that manage their data very well and their integration of systems very well are the brewing companies. But you get into some of the more sophisticated companies that have been doing it well for a long time and continue to evolve, or some of the specialty chemical companies. Pharma's really just beginning to make a move because they've been really constrained by the validation regulations. So as they move to process analytic technology regulations, they'll be able to, I think, have a bit of a renaissance there. But the people who have always led in intelligent plant systems have been the electronic and telecom companies, and they take it extremely serious and have been applying some of these methods for a very long time in those industries. Aerospace is just starting. Some of the most difficult cultural battles I've ever had to fight for systems have been in aerospace plants. So so there's I think that a lot of these industries, some of them are like Dell Computer, for instance, are way ahead of the rest, and then you have some of these industries which just can't get out of their own way because of their culture. They go through system failure after system failure for 10 or 15 years, and the blame game never solves the problem. They don't actually understand that it's a cultural issue, not a system issue. So.
Yeah. We have a question here dealing with system scale, and that is how does a small single plant manufacturer take advantage of MOM without spending millions? And getting beyond their capabilities?
That's the question of our age, because the issue that we have in our current generation of tools, which has improved dramatically in the last 15 years, is they're still too expensive for the 250,000 manufacturers, for instance, in just North America. So there's under $2 billion companies. There's over 250,000 manufacturers under $2 billion companies just in North America. And those companies basically have a very hard time affording these systems or even understanding how to go about applying them in what order for what business reason. We go through sort of the logic of how to determine that within some of the MESA Global Education Program classes, but the short answer is that the smaller plants, need to start with basically they're going to have a lot of paper that generated within departments, and those papers are rolled into databases which of some type that produces some kind of reports, and so at that reporting level and subsequently at that information level, they need to come up with a standard set of metrics and ultimately reporting KPIs and a standard operation management language. So whether it's in a system or in a paper-based or custom system or a standalone system, as you develop those systems, don't let your quality department just have put up their four walls. You need to harmonize the language that's used within your departmental applications, whether it's paper or system. And in the lean world, they call this, it's applying standard work in 5S methods. And so I'm not talking about anything really new. I mean, the concept of basically rationalizing the language that you use to make something in a plant is basically an old lean technology, a lean method. And I'm just saying that you need to apply it. You need to lean out your manufacturing IT systems, because it takes 15 to 20 systems to basically process an order. And that blows a lot of people's minds until I walk around their plant and I take an inventory of the systems across their departments that are associated with basically the making of their product.
Yeah, that is always a moment of revelation for folk.
Yeah, they say, well, what systems do I have? Oh, I have a ERP and an MES and I have some automation. And then I do the inventory and I show them that they actually have 15 systems that are needed to make something. Yeah,
quite remarkable. Well, we are approaching the end of our time here, and so we appreciate very much, Charlie, you spending the time with us to go through what you and your group have done and the implications of it for manufacturing. And we thank everybody for attending our conversation. So we will be posting a recording of this, and if you have any questions for either Charlie or myself or Adiempas at NWA, please feel free to contact us, and we'll try to track down the answers for you. And now there's Charlie's contact information.
And I'd like to extend a thank you to all the authors and reviewers. They worked really hard with me to produce this last piece of work.
I think we all should give a round of applause. It's good to see the work that you folk are doing. Okay, folks. Well, we will send you links to the recording, and please feel free to share that. And both Charlie and I thank you for your time today. And again, we look forward to seeing you at our next presentation. Have a good day.